In rail transport, the US DOT-111 tank car, also known as the CTC-111A in Canada, is a type of unpressurized tank car in common use in North America. Tanks built to this specification must be circular in cross-section, with elliptical, formed head set convex outward. They have a minimum plate thickness of 7/16 inch and a maximum capacity of 34,500 US gallons. Tanks may be constructed from carbon steel, aluminum alloy, high alloy steel or nickel plate steel by fusion welding. Usage: up to 80% of the Canadian fleet and 69% of U.S. rail tank cars are DOT-111 type. DOT-111 cars are equipped with AAR-type E-top and bottom shelf Janney couplers designed to maintain vertical alignment to prevent couplers from overriding and puncturing the tank end frames. Many of these transport a wide spectrum of dangerous goods, including 40,000 cars in dedicated service carrying 219,000 carloads of ethanol fuel annually in the U.S., hydraulic fracturing of new wells in the shale oil fields in the interior of North America has rapidly increased use of DOT-111 cars to transport crude oil to existing refineries along the coasts. The Montreal, Maine and Atlantic Railway runaway train in the Lac-Mars copyright Gantic derailment of July 2013 was made up of 72 of these cars, some of which ruptured, releasing explosively their cargo of Bakken Formation light crude oil, resulting in a large fire and mass casualty event. A November 2013 derailment near Ellisaville, in Pickens County, Alabama involved a similar explosion of North Dakota crude oil. The Genesee and Wyoming Company was the carrier for this 90-car train, of which 20 derailed and exploded. The train originated in Amory, Mississippi and was scheduled for a pipeline terminal in Walnut Hill, Florida that is owned by Genesis Energy. The final destination for the shipment was to have been the Shell Oil Refinery in Mobile, Alabama. The accident happened in a depopulated wetlands area. 3 cars experienced a boiling liquid expanding vapor explosion. On December 30, 2013, a similar explosion occurred in Castleton, North Dakota, causing the town to be evacuated. The BNSF train was 106 cars and 1.6 km long, of which at least 10 cars were destroyed. Reports were that another train carrying grain derailed first, causing the adjacent Bakken Formation cars to derail. 3 days later, the US DOT-PHMSA wrote that OE recent derailments and resulting fires indicate that the type of crude oil being transported from the Bakken region may be more flammable than traditional heavy crude oil. Based on preliminary inspections conducted after recent rail derailments in North Dakota, Alabama and Lac-Mégantic, Quebec, involving Bakken crude oil, we mandate crude producers and shippers to sufficiently degasify hazardous materials prior to and during transportation. The oil regulator for North Dakota stated in early December 2013 that he expected as much as 90% of that state's oil would be carried by train in 2014, up from the current 60%. The number of crude oil carloads hauled by U.S. railroads surged from 10,840 in 2009 to a projected 400,000 in 2013. In the third quarter of 2013, crude by rail shipments rose 44% from the previous year to 93,312 carloads, equivalent to about 740,000 barrels per day or almost 1/10 of U.S. production. That was down 14% from the second quarter of 2013 due to narrower oil spreads that made costlier rail shipments less economic. The US NTSB had issued guidelines about DOT-111 tank cars in March 2012 as a result of the 2009 incident in Cherry Valley, Illinois, but the Department of Transportation, which regulates the industry, still met resistance from the oil industry as of January 2014 over the estimated $1 billion to retrofit nearly 300,000 existing tank cars. On January 7, 2014, 17 cars of a 122-car train derailed and exploded near Plaster Rock, New Brunswick. Nobody was injured but about 150 people were evacuated. The petroleum products originated in Western Canada and were destined for the Irving Oil Refinery in St. John. Construction. The DOT-111 tank cars are constructed with a draft sill design. Draft sills incorporate the draft gear behind each cupola that is designed to transfer longitudinal draft and buff forces throughout the length of a train. The draft sills are attached to steel pads that are attached to the tank. If the cars do not incorporate a continuous center sill extending the entire length of the car, the two draft sills at each end are referred to as stub sills, and the tank carries draft forces between cupolas. In this case, reinforcing bars may be extended underneath the tank between the draft sills. Body bolsters and their associated body bolster pads centered above the rail car truck support the tank and protect it against lateral forces. The draft sill center plate serves as the attachment point between the tank car body and the truck assembly. The body bolster pads and front sill pads are attached to the tank with fillet welds. At the rear edge of the front sill pad, a butt weld attaches the front sill pad to the body bolster pad and to the fillet weld attaching the body bolster pad to the tank shell. Fillet welds at the interior and exterior sides of the head brace attach the head brace to the front sill pad, and an exterior fillet weld attaches the head brace to the draft sill. To the rear of the head brace, the draft sill is welded to the front sill pad, body bolster pad, and reinforcing bars. Because rail cars have no front or rear, for descriptive purposes, the ends of the cars are designated A and B. The B end of the car is the end equipped with a wheel used to manually set the car's handbrakes. The end without the brake wheel is the A end. As trains are assembled, either end of a tank car may be placed in the front or rear position. The tank shells are constructed of several rings welded together, with 6 rings in a typical configuration. By convention, ring 1 is at the A end, and if there are 6 rings, ring 6 is at the B end. The tank rings can be welded in a straight barrel configuration, or with a slope bottom sloping down to a bottom outlet valve at the center of the tank. Regulations. A 2013 Senate of Canada committee report proposed mandatory minimum insurance for rail companies and recommended the creation of an online database with information on spills and other incidents from rail cars. Currently, the railway industry lags the pipeline industry in value of mandatory insurance coverage, to a ratio of 1 to 40. Railway operators are not required to inform Canadian municipalities about hazardous goods in transit. DOT-112 tank cars and DOT-114 tank cars have been required since 1979 under Regulation SOA/79-101 of the Canada Transportation Act for the transportation of gases such as propane, butane, or vinyl chloride. Transportation Safety Board of Canada Railway Investigation Report 94/0029 Section 1.13.1 documents DOT-112 tank car and DOT-114 tank car standards. The DOT-111 tank cars are not considered to provide the same degree of derailment protection against loss of product as the classification 112 and 114 cars, designed to carry flammable gases. Accident Investigations. A report on the state of rail safety in Canada was commissioned by Transport Canada in 2007. The report contains a 10-year statistical examination of its subject. Section 6 is entitled Accidents Involving Dangerous Goods. A formal review of the Railway Safety Act was impaneled by the Minister in February 2007. The review, which was tabled in Parliament later that year, has a different take on the subject. Completed. During a number of accident investigations over a period of years, the U.S. National Transportation Safety Board has noted that DOT-111 tank cars have a high incidence of tank failures during accidents. Previous NTSB investigations that identified the poor performance of DOT-111 tank cars in collisions include a May 1991 safety study as well as NTSB investigations of a June 30, 1992. Derailment in Superior, Wisconsin. A February 9, 2003, derailment in Tamaroa, Illinois. And in October 20, 2006, derailment of an ethanol unit train in New Brighton, Pennsylvania. In addition, on February 6, 2011, the Federal Railroad Administration investigated the derailment of a unit train of DOT-111 tank cars loaded with ethanol in Arcadia, Ohio, which released about 786,000 U.S. gallons of product. The Transportation Safety Board of Canada also noted that this car's design was flawed, resulting in a high incidence of tank integrity failure during accidents. The Transportation Safety Board of Canada investigated a derailment incident near Westray, Ontario, which occurred on January 30, 1994. They cited Report NTSB-01, which questioned the safety of DOT-111 tank cars and determined that this classification of tank car has a high incidence of tank integrity failure when involved in accidents, and that certain hazardous materials are transported in these tank cars even though better protected cars are available. The TSBC instituted Amendment Schedule No. 21 to the Transportation of Dangerous Goods Regulations, which mandated the use of revised tank car standard CAN CGSB 43.147-94. This standard restricts the use of 111A tank cars, and removes over 80 dangerous goods previously authorized for transportation in Class 111 cars. The updated standard is available through the Canadian General Standards Board. Approximately 230,000 litres of sulfuric acid was released, causing environmental damage, on January 21, 1995 near Gouin, Quebec. The 11 rail cars that released product were standard series CTC 111A tank cars. The derailment was caused by gauge loss, and the number of defective ties north of the derailment area likely exceeded Canadian National's maintenance standard. Transport Canada determined that a retrofit of the top fittings of all Class 111A cars would exceed $1 billion. The Transportation Safety Board of Canada investigated an occurrence near Riverglade, New Brunswick, which occurred on March 11, 1996. The 1996 report concluded that Class 111A tank cars are more susceptible to release product upon derailment and impact than pressure tank cars, and yet there are a number of toxic and volatile liquids that are still permitted to be carried in minimum standard Class 111A tank cars. The report makes no recommendation to upgrade or limit the use of Class 111A tank cars. An investigative report published August 3, 2013 by the Brand & Son listed 10 railway derailments in the area over the past decade. Derailments caused no injuries over that period. On May 2, 2002, a train collided with a transport truck at the Firdale, Manitoba CN crossing. The derailed equipment included 5 tank cars carrying dangerous goods. During the derailment, 4 of the tank cars sustained multiple punctures and released their products. The products ignited and a large fire engulfed the derailed cars. The United States National Research Council was commissioned via the U.S. Hazardous Materials Transportation Uniform Safety Act by the Federal Railroad Administration to write an impartial report on 1. The railroad tank car design process, including specifications development, design approval, repair process approval, repair accountability, and the process by which designs and repairs are presented, weighed, and evaluated, and railroad tank car design criteria, including whether head shields should be installed on all tank cars that carry hazardous materials. It is entitled Ensuring Railroad Tank Car Safety, and available as ISBN 0-309-05518-0. LACMA copyright Gantic derailment. Questions have been raised by the Transportation Safety Board of Canada investigators regarding the contents of the LACMA copyright Gantic train, because the crude oil acted in a abnormal unregistered trademark way. The Enbridge Corporation has complained numerous times to U.S. regulators that Bakken unregistered trademark crude oil is volatile. This situation is similar to those that were detailed 12 years earlier in the Hazardous Materials Accident Report on the rupture of a railroad tank car containing hazardous waste near Clemmers, Indiana. One issue raised by the LACMA copyright Gantic derailment, and substantiated by Enbridge complaints to the U.S. regulator, is that Bakken crude oil is associated with a notable volatility. The U.S. Federal Railroad Administration moved on August 8, 2013 to tighten standards for shipments of crude oil from the Bakken Formation fields that contain volatile and/or corrosive chemicals, such as may issue from the hydraulic fracturing process. Crude oil is classed as HAZMAT Class 3 flammable liquids. The U.S. regulator had ignored until August 8, 2013 the corrosive contents of Bakken Formation crude oil. The immiscibility of crude oil and acid causes the acid to settle to the bottom of a container, and this may add to the corrosion. Given that a substantial fraction of rail stock is of DOT-111 type, the shipment of Bakken Formation crude oil risks becoming more expensive over the medium term as the DOT-112 tank cars necessary for shipment will initially be relatively scarce. Hydrogen sulfide, a gas which is toxic to humans and flammable, has been detected as well in Bakken crude by Enbridge. The academic community commented in 2011 that increased concentration of H2S was observed in the field and presented challenges such as health and environmental risks, corrosion of wellbore, added expense with regard to materials handling and pipeline equipment, and additional refinement requirements. Holubniak al. Wright, further, that Bakken crude may become soured through current oil field practices. At issue in the LACMA copyright Gantic derailment, then, is whether World Fuel Services and other defendants ought to have been aware of this 2-year-old research when they ordered the DOT-111 tank cars to be loaded on the LACMA copyright Gantic train. The LACMA copyright Gantic runaway train had earlier passed through Toronto on its way from the Bakken fields of Dakota. A Canadian national employee said that roughly 10% of shipments through Toronto contain hazardous materials that are often stored on DOT-111 tank cars, but that only first responders have access to HAZMAT shipment information. New construction standards. As a result of an accident in Cherry Valley, Illinois, in 2009, the Association of American Railroads studied several options for increasing the crashworthiness of DOT-111 tank car designs and published new construction standards in a casualty prevention circular, with the intent to revise the AAR manual for standards and recommended practices for tank cars that are used to transport ethanol and crude oil. Beginning on October 1, 2011, the new AAR standard for DOT-111 tank cars requires tank heads and shells to be constructed of thicker steel. The new specification also requires that heads and shells be constructed of normalized steel, and in all cases 1 or 2-inch thick half-head shields must be provided. The AAR has also mandated a more robust housing or rollover skid for protection of top fittings. The new standards only apply to newly manufactured cars. There is no requirement to retrofit, repurpose, or retire existing DOT-111A cars built to the older design. The NTSB has called that design inadequate, noting the older cars are subject to damage and catastrophic loss of hazardous materials. See also, Pipeline and Hazardous Materials Safety Administration, references. This article incorporates a public domain material from the National Transportation Safety Board document Unclassified Safety Recommendation R12-005-008, March 2, 2012. This article incorporates a public domain material from the National Transportation Safety Board document DOT-111 tank car design. This article incorporates a public domain material from the National Transportation Safety Board document Derailment of CN Freight Train U70691-18 with subsequent hazardous materials release and fire. Cherry Valley, Illinois. June 19, 2009.